Good morning. Introduction of Euclid's geometry. Geometry is a branch of mathematics which deals with the properties of shapes. The word geometry is derived from the Greek words geo and metron. Geo stands for the earth and metron stands to measure. So geometry means to measure the earth. This branch of mathematics was studied in various forms in the ancient civilization. The people of the ancient civilization faced several practical problems which required the development of geometry in various ways. During those days, developments of geometry were passed on from one generation to the next, either orally or through palm leaf message or by other ways. Thales. He was a Greek mathematician. Thales is credited for proving the statement that a circle is bisected by its diameter. And the introduction of geometry is credited to Thales, who is considered as the father of mathematics. Thales' most famous pupils was Pythagoras. You might have heard about Pythagoras by Pythagoras theorem. Pythagoras and his group discovered many geometric properties and developed the theory of geometry, which continued till 300 BC era. Euclid, who is considered as the father of geometry. At the time of Euclid, a mathematics teacher at Alexandria in Egypt collected all the known work and arranged it in his famous treatise called Elements, which was divided into 13 chapters. Each was called a book. This Greek mathematician thought about geometry as an abstract model of the world in which they lived. Like a solid has shape, size, position, and can be moved from one place to another. Like when we consider the shapes like a cuboid or a solid or a surface, line, a point. When we consider a solid, it has three dimensions. A surface has two dimensions. A line has one dimension and a point has none. And there are a few basic definitions of geometry which starts with point. So what is a point? A point is a dot made by a sharp edge and which has no parts. A line is breadthless length. The ends of lines are points. A straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth only. The edge of a surface are lines. A plane surface is a surface which lies evenly with a straight line on itself. Axioms and postulates. Euclid assumed certain properties which were not proved but were actually obvious universal truths. He divided them into axioms and postulates. Postulates are terms used for the assumptions that were specific to geometry, while axioms are terms used throughout mathematics and are not specifically linked to geometry. Euclid, who is considered as the father of geometry, wrote down many assumptions which are obviously universal truths. Few assumptions are meant for all mathematics, and a few assumptions meant only for geometry. So Euclid have made many assumptions, and those assumptions were natural truths which do not require any evidence. Okay, like a straight line may be drawn from one point to any other point. It's a natural fact. A straight line may be drawn from one point to any other point. It's a universal fact. So we can call it as a natural truth. So this is one of the assumptions made by Euclid. Okay, and he made the assumptions in which a few are meant only for geometry and a few meant for the whole mathematics. The assumptions which are specifically for geometry are known as postulates. So what are postulates? So postulates are the assumptions meant only for geometry. So here let's discuss 5 postulates before going to the axioms. Postulate 1. A straight line may be drawn from any one point to any other point. So a straight line may be drawn from any one point to any other point. So from one point to another point, a straight line can be drawn. This is a basic fact we all know. Okay, and it does not require any evidence, and it is being only in geometry, so it is known as a postulate. So first postulate is a straight line may be drawn from any one point to any other point. Postulate 2. Given two distinct points, there is a unique line that passes through them. So what do you understand from this statement? Given two distinct points. So let's take two distinct points. Means two different points. There is a unique line. That means there is one and only one line which passes through these 2 points. Through the point A, we can draw infinite number of lines. Through B also we can draw infinite number of lines. Isn't it? Through A, we can draw infinite number of lines. Even through B, we can draw infinite number of lines. But among these infinite number of lines, there will be one and only one line which passes through the other point also. So there exists only one line which passes through both the points. That is postulate number 2. Postulate number 3 is a terminated line can be produced indefinitely. So what do you mean by a terminated line? In other words, we can call a terminated line as a line segment. Okay, a part of a line, that is meant by a terminated line, a part of a line. So let's consider a line segment AB. What Euclid says that this terminated line can be extended indefinitely in both the directions. That means this line can be extended indefinitely in both directions. That is meant by a terminated line can be produced indefinitely. Fourth postulate is all right angles are equal to one another. You know what is a right angle? It's an angle which makes 90 degree. So wherever you find a right angle, it gives us the answer 90 degree. So it's very clear all right angles are equal to one another. Axiom number 5 states that if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. So what did you get from this sentence? Okay, let's check from first. If a straight line falling on two straight lines makes the interior angles. So let's start from here. If a straight line falling on two other straight lines. So totally how many straight lines we have? Yes, there are three straight lines. Okay, so this straight line falling on the other two straight lines. It may be like this. Or it may fall like this. See here, see a straight line falling on other two straight lines. Okay, makes the interior angles on the same side of it. Makes the interior angle. You see here, when you check, there are interior angles are formed. You look at this interior angle, means angle formed inside the lines. These are two interior angles. These are other two interior angles, isn't it? So totally there are four interior angles so formed, even here also. This is one interior angle, second one, third one, fourth one. So what are the interior angles we want? The interior angles on the same side of it. We want the interior angles on the same side of this line. Interior angles on the same side of this line. Suppose this is a line which is the interior angle on the same side, which is the pair. Yes, even you can take, if this is an angle, its next pair will be this one. Or if this is an angle, its next pair will be this one. Isn't it? That is meant by interior angles on the same side. Okay, so as per our question, let's take interior angles on the same side. Let's take these two. If they add, if we add them, if their sum is less than two right angles, if the sum of these two angles is less than two right angles. What do you mean by less than two right angles? Yeah, it's nothing but 180 degree. So if the sum of these two angles is less than two right angles, okay, for example, I'm taking an angle here, another one here. Suppose this angle is 85 and this angle is 70. So we got two angles, one angle is 85 and the other one is 70. So that their sum is 85 plus 70, which is 155. It is less than two right angles, no? Means it's less than 180 degrees. But if you take this side, you see, these both are obtuse angles. So their sum will be more than 180 degree. Here also, you have to check both the sides. Okay, so if the sum of these two interior angles is less than 180 degree, then the two straight lines, if produced indefinitely, then if we produce these two straight lines indefinitely, if we produce both the straight lines indefinitely, they meet at a point. They meet at a point. Where they meet? On that side on which the sum of interior angles is less than 180 degree. In which side you get sum of two interior angles is less than 180 degree, in that side they meet each other. Okay, but when you check these two straight lines, you find out here whether they meet. Let's produce it. Will they meet at any point? No, they won't meet at any point because those two lines are parallel lines and the sum of these two angles is always two right angles. That means the sum of these two angles is always 180 degree. Similarly, the sum of these two angles also 180 degree, exactly 180 degree. Then they never meet each other. If it is less than 180 degree, if the sum of these two angles is less than 180 degree, then when we extend both the lines, they meet at a point on which the side where the sum of the two angles is less than 180 degree. Okay, that is meant by postulate number 5. Let us check 3 examples related to postulate number 5. So when you check the first example, there are two interior angles on the same side of this line is given. They are 130 degree and 50 degree. So when you take the sum of these two, we get 130 plus 50 as 180 degree, which is two right angles. That means they do not meet each other. If we extend these two lines, they go indefinitely because those two lines are parallel lines. When we check the second example, the two interior angles are given here. When you add them together, we get 110 plus 60. 110 plus 60 is 170, which is less than two right angles. So if you extend this line, they meet at a point on the side in which the sum is less than 180 degree. If you extend here, will they meet each other? And when you check the third example, here this interior angle is 120 degree and this is 150 degree. And when you check the sum of these two, 120 plus 150, we get it as 270 degree, which is larger than two right angles. So when you extend the line to this side, they won't meet each other. Then where they meet? To this side. That means if this side is more than 180 degree, this side will be less than 180 degree. Okay, that is postulate number 5. And here the first example refers parallel lines and next two examples refers intersecting lines. So these two lines are known as intersecting lines. We discuss about this type of lines in detail in the chapter lines and angles. Axioms. Axioms are also the natural truths or assumptions which is meant for the whole mathematics. Just recall what is postulate. A postulate is an assumption which is meant for only geometry, but axioms are also assumptions, natural truths which meant for all mathematics and do not require any evidence, because the axioms and postulates are self-evident statements. Axiom number 1. Things which are equal to the same things are equal to one another. Or quantities which are equal to the same things are equal to one another. And when you check this sentence, you can understand this is not only meant for geometry but for all mathematics. So what is meant by this sentence? Things which are equal to the same things. Things which are equal to the same things. Let's take one example. Let's start from geometry itself. Let's take a line segment AB which is 10 centimeter. Let's take another line segment PQ which is also 10 centimeter. So these two things are equal to 10 centimeter. That is meant by things which are equal to the same things. Things which are equal to the same things. So two things are here, the line segment AB and PQ, they are equal to the same thing 10 centimeter. Then we can say they are equal to one another. Then these two things will be equal to one another. That means AB is 10 centimeter and PQ is 10 centimeter. From this we can conclude that AB is equal to PQ. Okay, this is the first axiom. Another example we can say from algebra. Let's take a variable x which is equal to a. Let's take another variable y which is equal to a. So x and y are two variables have the same value. X has a value a, y also have the value a. That means x and y have the same value. So two things x and y are equal to the same thing a. Then we can say x is equal to y. Okay, this is the first axiom. Second axiom, if equals are added to equals, then the whole are also equal. If equals are added to equals, what do you mean by this sentence? If equals are added to equals, just I'll tell you one example. You know, 5 is equal to 5. That is, there are equals. If equals are added to equals, now we are adding equals on both sides, like let it be 3. So there are two equals, 5, 5, and an equal number 3 is added on both sides. So we get the result as 8 on both sides. It means that is also equal. In normal sense, we'll say balancing the equation. When we add a term in one side, add the same to the other also. To balance the equation, we'll say. Okay, another example. We have a weighing balance. Both sides. The left pan we have 10 kg weight, and the right pan we have 10 kg quantity, maybe rice. Okay. Now, so we have two equal quantities on both the pans. Now let's add a 5 kg on both sides. So what happens to the balance? Yes, it still remain balanced. But if we add this 5 kg only in one side, what happens? Become unbalanced. If we add in the other side, again it become balanced. That is meant to be, if equals are added to equals, then the whole are equal. In addition to this, we can say the third postulate also. It's nothing but if equals are subtracted from equals, then the remainders or the balance are also equal. This is the third axiom. That means from this 10 kg, if you subtract 5 kg from both sides, from both panel, the resultant answer also will be equal. That is meant by third axiom.